When you're looking at a circular economy, you need to be looking at the value of the material. And that's where examples of buildings as material banks and actually realizing that that piece of plasterboard will have X amount of value if you are in conversation with, say, the likes of British Gypsum, and they say, yeah, we can take that board back, we can use it. That has a little bit of value. That is a far more reliable metric than just saying X amount of mass equals that amount in terms of pounds, which doesn't seem to make any sense.
Bit arbitrary.
Yes.
Yeah. Hello, and welcome to Be Sustainable, where we turn complex ideas about sustainability into real-world solutions for the built environment. In today's episode, we will be discussing the circular economy in the context of the built environment. With me today, we have Dr. Pippa Boyd. She's a senior lecturer at UCEM and leads on the MSc in Innovation in Sustainable Built Environments. Her experience straddles academia and industry with a background in mechanical engineering, production methods, and change management. Pippa's PhD explored the uptake of sustainable innovation in the built environment, and her research is particularly focused on construction technology. Also here today, Dr. Ankit Singh. He's a Director of Sustainability at Waterman Building Services Limited, part of the Waterman Group. He leads the charge in implementing strategic sustainability initiatives in the construction sector. He collaborates closely with asset funders, developers and contractors to foster sustainable development across various projects and sectors. His academic background includes a PhD in making sense of strategy development for sustainability in large construction firms in the UK, and has further qualifications from MIT and the University of Cambridge. Welcome, both of you.
Thank you.
Thanks for coming in today. So let's start off with the simple but big question. What do we mean by circular economy? Ankit, would you like to start us off on this?
The concept of circular economy has been around for years and years. It's not a new concept. Mm-hmm. It's the fact that we're moving away from the take, make, break cycle to a circular cycle that looks at maximizing the value of any material. So you're maximizing its use, its potential, and its lifespan across the built asset's life.
Okay. And specifically within the built environment, what are the key facets of the circular model, Pippa?
There is a sort of a hierarchy about our materials. I mean, first of all, I'd like to say the circular economy has got two areas, really. It's kind of the green of the sort of the more environmental areas in terms of reusing our resources, but also the sort of the technological aspect. And we're concentrating rather more on that technological aspect within this discussion. Mm-hmm. And because of that, we now talk about, at home it's sort of reuse, recycle, use less. And they're the similar concepts within the circular economy, I think. Mm-hmm. You know, let's see if we can maintain the value of things rather than breaking them down to the next level down.
Yeah.
And keep things within the built environment rather than using more and more resources.
So partly about extending the lifetime of components, but also about reducing the environmental impact by reusing rather than creating and using new every time.
Yeah.
Okay. Ankit, could you give us some specific examples to sort of illustrate the sort of thing that we're talking about?
So there's a big push right now, and I think that's primarily coming because of the expense of resources at the moment. Mm-hmm. Resources are expensive, so the industry started to look at existing buildings as material banks, starting to look at materials in a slightly different way and looking at ways to start to reuse them rather than buying anew. And I think that's where there's a big step up in the industry to look to retain rather than make anew, which is causing the market to suddenly look at buildings in a slightly different way, more from a material value point of view rather than just an asset value, that the traditional metrics such as financial metrics. They're now looking at it in material value as well. There is an implication for carbon because obviously if the material has been in a building for more than 60 odd years, it's decarbonized. Therefore, it is effectively decarbonized material. Yes, and there is an element of insurance and warranty and the rest, which we'll unpack through this discussion.
Sure. Are there any notable examples of projects recently that are flagships for this kind of initiative?
So one of our projects done by the Waterman Group, Edenica or 100 Fetter Lane in the city, is one of the first few projects in the city to actually trial material passports. Now, when we started this project, obviously there's not much guidance in terms of material passports. And the reason we looked at material passports was because the city was very keen to reduce carbon in that building. So while they want you to build new, it doesn't come at a cost of excessive carbon. So how do you monitor it? How do you quantify it? And that's where, from a circular economy point of view, it was kind of discussed that material passports would be a useful way of tracking these materials. So essentially, the building frame, the raised access floor, and the concrete for the facade was actually selected to trial out to see if we are able to then identify where the material has come from, what its performance levels are, and how we can then monitor it moving forward.
Okay.
I think that's a really interesting one, because that is a building from scratch where you're setting yourself up to become a circular economy model. I think that there are a few showcase examples of people trying to then sort of unbolt, reuse elements that have already been in stock, but they're really relatively small, because you can't dismantle something if it hasn't been designed to be dismantled.
Yeah.
And there are various initiatives around. I mean, you can have modular buildings, which are, once they're manufactured, can be taken back, slightly reconfigured, and then sold on again as a sort of a reused model, maintaining the value of the components. Or you can hire out various lighting components and use those as a service, so that if you're stripping, not even lighting, internal finishing, if you're stripping that out of a building, you can perhaps reuse it somewhere else if it's designed to be dismantled. So I think there are rather a lot more smaller scale, and there are a few buildings around that are reusing components from different buildings, but that's quite difficult at the moment because A, we don't know how to dismantle properly. B, we don't have issues about, we don't understand really how to underwrite the risks involved in our current understanding of contracts. And we also just don't know how to design buildings that way. So,
yeah. Just to kind of come in on that, there's also a performance aspect that's governing these buildings in a way, because we're moving into the realm of net zero. And those limitations that applies to the building in terms of its performance can almost discount a few materials. Like facade retention becomes challenging purely because you're not going to be able to achieve the levels of net zero that you would require of that building. And that's where it starts to crash. The sector almost crashes against itself, because it doesn't allow for a building to be net zero yet retain most of its elements when the building performance is under consideration.
In that sort of sense, are we talking really about two different streams? That there are new projects and there are projects which retain elements of the original structure. So a building or a construction has an extended lifespan, and then others where we are reducing the carbon impact of a new build because we're bringing...
I think there's an element of that, because one thing that we need to note is that 80% of the building stock that's going to be there in 2050, where we met our net zero commitments, is already here.
Yeah.
So retention is a big facet in that. The key focal point for net zero, when you're talking about a retained asset, is reducing the demand. So that means improving fabric performance, looking at ways of optimizing the floor space for better use, et cetera, which kind of limits what you're able to achieve in terms of your performance gains. In terms of what the commercial sector is looking at, there's definitely been a big uptake on essentially heavy retrofitted buildings in the last few years, where blue chip companies are not looking at new builds alone. They're also looking at retained buildings with new elements to it, where you're then starting to look into a realm of a hybrid building, essentially, where you've got a significant retained portion with additional weight balanced floors on top. And then the new build has to be of that exemplar level of net zero in order to make that 2050 commitment come alive.
I think that's interesting in itself, because that hybrid, if you're replacing one office for another, your floor plan's not going to be too dissimilar. You might, retain the core, or you might actually remove the core and put a new core somewhere else, but retain the frame. And that's okay for perhaps offices, but if you're starting to try and build in flexibility for long-term use, then it's a little bit of a different design philosophy. And it may well be that building from new is the only way to bring that degree of flexibility in. So it's very much this dance about building performance, embodied carbon, and longer-term use.
And there's a part of flexibility that I really struggle with, because essentially when you're looking at retained buildings and when you do go through this load balancing method of adding a few floors on, essentially what you've done there is that you've taken that flexibility away from that building for a future retrofit. You've almost maxed out what the building itself could do. And that's the bit that I kind of struggle with in terms of circular economy, is that you've effectively ended up with a stranded asset in terms of its flexible use, its adaptable use. And then because you're almost limiting opportunities once you've done that. But at the same time, you're doing it also to give value and life to the building or an asset which is probably stranded at that moment.
So have you got an example of that?
There are quite a few buildings in London that have currently gone through this way. If you go through it, you can see that they've got the 1920s or 1900 facades on the outside. And then you've got masses of basement construction, which is not great for carbon. But there is extension on top. The Claridges did a really, really good job with a hotel where effectively they were able to go 6-story down with a functional hotel on top. And then they added on two or three floors. But my worry then is that building is now at this maximum value in terms of circular economy. Mm-hmm. Can you then do a similar sort of intervention for a different use or a different change further down the line? And that's the bit that has to be explored further in this space.
Because that building is now its only ever Claridge's.
Well, exactly.
So it would need something far more significant, a far more significant intervention to make it applicable for a different end user.
Yes.
Right. Okay.
So does that also mean that when we're thinking about these sort of deep refurbishments, we should be thinking about dismantling and reuse at that time?
At every opportunity you can in terms of the intervention, because it's probably not been thought of earlier. So can you engineer that solution in? Or can you engineer that solution for the new build elements where you're effectively bolting it on and bolting it off the building, which still retains that flexibility? And that's my big concern, is that, yes, that is what most planning authorities will push you towards, is whether they're realizing that you're actually capping out the building potential by doing so. And it's actually the construction methods at that point which will govern its circularity and the circular use moving forward.
Which brings us back to Pippa's earlier point about buildings not being designed to be deconstructed, redeveloped in this way. And presumably that then affects the paradigm going forward for how to design a building.
One of the biggest things about the circular economy and its successful development depends on new business models. And not only new business models, but new interactions and new ways of doing things. And so the easy example is the architect who at the moment leads the creative development of a building and has resulted in some truly beautiful buildings and some very unique buildings. And if we go down the track of actually we're going to have to design for disassembly and we're going to have to design for reuse rather than recycling, which are two slightly different concepts, then the architect is actually going to have to work with rather less flexibility, perhaps. So it's more like working with a kit of Lego or Meccano parts to make something new and interesting, but which can be dismantled and reused in a different way.
I imagine some architects would find that quite stifling.
Well, I think architects might find that stifling to a certain extent, but from what I'm seeing in the industry is the architects are actually leading that charge. Okay. They're very happy to embrace this because it's bringing a new dimension to the design, which didn't exist for some time. And what they're starting to see more and more is there's actual commercial value for it. Obviously, there is that underlining principle that there is a way of differentiating yourself in the market, and this is one of the key methods of doing so. But what that also does is it's not just the architects that are going to be involved in it. The structural engineers play a big role in this. Them being able to understand the building structure becomes imperative, and what that building structure is able to do for the next 50 to 100 years. Because essentially you're talking about buildings that have already stood for about 50 to 100 years that are going to have that level of interventions. And there is a point to say, why is it that we are still pulling down some of those buildings? But I think that will be unpacked as well in some of this. Building services engineers are actually very key in this because they have to almost operationalize the performance of the building. So they have to work even closer with them, make it easy to disassemble, make it easy to repair, easy to maintain, because that's what will have impact on the carbon emissions of that building and will have very real value impact in terms of the building performance.
We've talked a lot here about buildings. Can we come back to something that you were talking about earlier on, Ankit, about material passports and talk a little bit around the components of which these buildings are made rather than the whole building? Can you just walk us through the material passport concept and how it's implemented currently?
So the material passport framework actually came about when we started to look at the components for Adenica and to be able to track where those materials were coming from, how those materials will be logged and tracked through its building lifespan. Now, the material passport concept is not new. The EU has had it implemented in law for many, many years. They've had battery passports that have been very successful. So effectively, the digital product passport has existed for a while. And the material passport itself is like you have a passport for yourself. It does the same thing for a material. And the application of it for the building was quite easy because we picked the elements that had the most amount of carbon in it to be able to track first. And the concept of the passport is to give that material identity, to be able to say this material comes from some extraction mine here, it's been processed in this factory, it's then made its way through different methods of transport to the final assembly point and has been installed in the building. That is the passport identity point of it. But the key area of focus was monitoring how that material retains its value through its lifespan. So the passport should be treated more like a live O&M manual, which has to be routinely updated, which has to give effectively the material its service life and service history, so that when it comes to disassembly, you've got the provenance in there, in that documentation to say, that material has been used in such way, it's been monitored, it's been looked after in this way, and therefore it has X amount of value. That enables the circular economy. Mm-hmm. Now, to give you the idea of what we currently go through when we're looking at materials in buildings, is we have to go through tranches of documentation which is not properly maintained, where you've essentially local authorities usually get rid of drawings within 12 years of the building being constructed. Archives are not very well maintained. Therefore, the lack of knowledge of that building makes it really, really difficult to understand what value that material might have without intrusive surveys. So the idea is, at least for what we're building new, we avoid that sort of issue where we're missing out on that data. And the material passport is a method and that keeps that data alive within the building through its building lifespan.
So can I have a materials passport only for new materials, or is it just more accurate and more reliable for newly manufactured materials?
Well, in terms of the accuracy, I think we are still going through the learning phase in terms of the accuracy, and the accuracy is only as good as the data that's available. We went through a process of producing EPDs for many years, and till now, I think it's very obvious that it's not really worked within the industry. We are all aware of it, but it's too expensive to maintain, and it doesn't really capture the data that we need. The material passport is trying to kind of do away with that to a certain extent, to give you more of a reliable source of information, because you're dealing directly with the manufacturers, and then you're dealing with the contractors that are purchasing it and how they're installing it. So that's where the data is coming from. And it's a very robust process that's being followed through the Waterman Material Passport framework.
So I'm going to jump in because there's a question about who owns the material passport. Is it the building owner? Who's responsible for actually maintaining those logs? Is it the person who's living in the building? There is that whole, how do you maintain the data and how does that flow through and how does that value work?
So essentially, it is owned by the building owner. Like your service history is owned by you. When for your car as well, you've got the service history. It sits with your car. Essentially, that's exactly the concept that's been applied to this. In terms of who updates it, it is those engineers that are actually working on the building, that are actually maintaining the building, that are actually part of operating the building, that are... Now, you can always ask me and say, well, what's the difference between that and a O&M manual? The difference is, firstly, it's a digital product passport, so it's a little easier to maintain and operate. And then coming back to your question about existing buildings, when you're looking at materials that's already in there and you start to look at those buildings as material banks, you do have to do intrusive surveys. There is a method now that iStruct have come up with and ICE have come up with to validate structural elements. There is a process that has to be followed, especially for structural steel. The Institute of Steel has done that as well, which can then be validated and then be passported at that point. So you don't have to worry about it. And we're trying to do the same to roll it out to different elements within that building to be able to start to realize some value. Because at the moment, the process is manually very heavy. We have to go in, do intrusive surveys, review extensive documentation, drawings that are outdated, and then be able to kind of cobble together a pre-demolition or a pre-redevelopment audit, which says, that's possibly what's in the building, but you will not know until the demolition contractor gets in there and actually does those intrusive surveys and pulls out and says, you've got it completely wrong. This is what's actually in that building.
Yeah. Which, Pippa, you and I have talked before about standardisation and measurement around this. And this, I think, will be more important, and particularly as we get to talk about regulation and governance around this piece. Where are we in terms of being able to measure this?
I'd kind of ask another question, which is, what's this? Is it the degree of...
the degree of circularity is, I think, probably what I was thinking of.
And I think that's a really difficult measure. I mean, are you measuring how much has been reused at a particular level, how much has been recycled? Are you measuring the proportion of recycled material in another product, which actually means your material passport then has to become a very complex document, because as you reuse materials or recycle materials, you have a different percentage. For example, aluminium, is it pre-process or is it post? And if that determines how you classify the material. So I think measuring it is one thing. How do you put a value on it is another question. You know, is a brick that's come out of the factory the same value as a brick that has been in a building for 60 years? How do we know that? So I think measurement is a really difficult thing. How do you measure how circular a building is? And do you give priority to different levels within that circular argument?
And I think that's where you come into the realm of whole life carbon to a large extent. And there are certain measures that are being looked at in terms of evaluating a building in terms of its intrinsic carbon value and hedging on those values to say that building is potentially going to have X amount of decarbonized elements in it. So therefore its value is actually higher. But the same thing now, post-Grenfell, you've had lots of buildings having to go through deep retrofits and some of them being pulled down because obviously the value of retrofitting is not viable. You're ending up with a lot of good elements that are just being demolished and thrown away. Or, I mean, to a large extent, it's avoiding landfill, but it's not being utilized in its current form. So how do you measure that? How do you actually validate that? It becomes extremely, extremely difficult. For the GLA, we've got to report it in terms of mass, because that seems to be a base metric that everyone understands.
But mass isn't value.
No. So you put a value to that mass of recycled content. But I think when you're looking at a circular economy, you need to be looking at the value of the material. And that's where examples of buildings as material banks and actually realizing that that piece of plasterboard will have X amount of value if you are in conversation with, say, the likes of British Gypsum, and they say, yeah, we can take that board back, we can use it, that has a little bit of value. That is a far more reliable metric than just saying X amount of mass equals that amount in terms of pounds, which doesn't seem to make any sense.
Bit arbitrary.
Yes.
Yeah.
Well, and it takes no account of the processing costs and all of those. And I think it's also really difficult in terms of composite materials. So, you talked earlier about the material passport. Now, very simple for a steel beam. But as soon as you start to have a floor that's sort of steel and concrete, and it's hybrid and fused together, that's a very different. How do you associate a value with that? How do you do the value? How do you put a value on the additional process costs of a floor like that?
It's quite interesting you bring that up, because we've actually trialed that on one of our recent projects. We're currently looking through it. It's just been through planning, and unfortunately the building is going to be demolished. It's in the City of London. Working with the structural colleagues, essentially what we've said is that structure still has it's a concrete frame building. There's a lot of concrete in it, and like you're saying, the steel and the concrete is fused. But essentially what you've ended up with is a ribbed floor slab, which, if treated correctly, can be cut up, and then those can be used as T-beams in the new building. So the architect has worked very closely with the structural engineer to say, yes, that strength can be validated for another 50 years. It can be warranted. We'll utilize it in our lobby space because it's great. So it's about how you extract and how you deconstruct the building is where you realize that value.
So that goes back to the sort of the business model has to change. Yeah. We have to change how we think about design, how we think about what we can design. We joked a little bit earlier about whether you can actually recycle plasterboard. You can do that in two ways. You can either say, okay, I'm going to send it back to British Gypsum to put in as feedstock, or I'm going to just make our panels a little bit smaller. So we should cut out a little bit and use it somewhere else. And I think there is this, your example was a lovely example of, using the floor to make a different component, but keeping the value of that.
You're trying to retain as much as possible.
Yes.
And going back to our concept of circular economy, you're trying to maximize value. And where you can't maximize, you can't. But you've got to at least try. And I think that's where the industry has changed a little bit. It is trying, quite honestly, on this.
But the value isn't the value of the raw material. The value is the value of the component that you have, which is a different thing.
And it's also about how you view the component, because a component could be almost the entire wall build-up, for example. You can take that entire bit out, not just bit by bit. So you can, and that brings me back to the material passport framework. You can go down to component level, and you can go up to building element level. So, and that's how it should be treated in terms of circular economy. You can look at it in different levels.
Given the challenges that we're having in not identifying what the circular economy is, but the way it could work, is there a risk in all of this that it could be that smoke and mirrors could be applied, and that there is an element of greenwashing underneath this for the more cynical operator?
That has existed in the construction sector for some time now. But recently, legislation has changed. There's a bit more teeth now, with the FCA coming in with the way you declare your climate credentials. And in terms of how it applies to the built environment, we've got examples of, for example, a seller's energy performance certificate versus a buyer's energy performance certificate. There's always been a disparity between the two, because it depends on who's done it and the way they've done it. What are the assumptions behind it? You'll always have that. And I think we're getting a lot better. We've got the new whole life carbon RICS version 2 that's out to allow that robustness in the data collection. And like I said, we're implementing elements such as material passports is all about preserving that provenance to avoid that scenario. But unfortunately, that element of greenwashing will always be around, and it's about being able to point at it and be able to pull it up,
to challenge it
it. Yes.
Yeah. Okay, I'm going to draw us to a close in a moment. I think we've more or less run out of time for this episode. But Pippa, final word to you on this, if you have a comment.
As Ankit says, it's always going to be there, but I do think that it's a little bit like ESG statements or performance of buildings. It has become more mainstream. It has become a demand. It has become financially important. And as there is a sort of an economic impact of not doing this, it will become less a question of greenwashing and more a question of sort of business as usual. But we may be a way down the track for that.
Okay. And I think we will shortly be recording another episode around the implementation of this and the realities of this. And I think part of that will be how to regulate, how to maintain one's reputation, and how to win work, within this sort of structure. So I think that will be an interesting next development for us. But for today, I think that's brought us to our time for today. So Pippa, Ankit, thank you both very much for your time today.
Thank you.
So thank you, everybody. I hope you have enjoyed that discussion. This and all episodes of Be Sustainable are available on the usual platforms, Apple, Spotify and YouTube. Please do subscribe if you found it interesting, and watch this space. There is more to come. Thank you.